With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us solve this question. The question says that statement 1 para-nitroaniline is more polar than nitrobenzene, and statement 2 nitro group has minus M effect. Option A, statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Option B, statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. Option C, statement 1 is true, statement 2 is false, and option D, statement 1 is false, statement 2 is true. So in this question, two statements are given, statement 1 and 2. We have to check whether these statements are true or false. So in first statement, it is given para-nitroaniline is more polar than nitrobenzene. Now let us see. We have to see the polarity. So we have this is nitrobenzene, nitrobenzene. Then we have here NH2 and here NO2. This is para-nitroaniline, right? Now this is para-nitroaniline. We have to find out that which of the two is more polar. Now for polarity, we have to see their dipole moment. So if we draw the bond dipoles, now we will consider this bond between carbon and NO2, and here also we will consider the bond carbon between NH2 and carbon between NO2. Now we know that NO2 basically NO2 is a group which is electron withdrawing in nature, right? It is electron withdrawing in nature, so it shows minus M effect when it is attached to the benzene ring. It shows minus M effect. Minus M effect means minus R effect. It will withdraw the electron from the ring towards itself. Then here we have NH2 and NO2. Now we know that in NH2 nitrogen has a lone pair, so it has tendency to donate the electrons, so it is electron donating in nature, right? So it shows plus M effect. It shows plus M effect, so it will donate this pair of electron to the ring, right? Now here we have NO2, which will show minus M effect, which will withdraw the electron towards itself from the ring. Now always remember, when we draw bond dipoles, then the direction of the bond dipole is in the direction of the movement of electrons. Now we have NO2, so it will withdraw the electron towards itself. So the direction of bond dipole will be like this, right? And in NH2, electron will move inside the ring, so the direction of this bond will be like this. And in this bond, carbon and N nitrogen. Now here NO2 will withdraw the electron towards itself, so the direction of bond dipole will be like this, right? So in nitrobenzene we have only NO2, right, due to which the direction of bond dipole is in upward direction. But in para-nitroaniline, both NH2 and NO2, due to both the groups, the bond dipole is in downward direction. So net result of dipole moment will be greater in para-nitroaniline. Now if we see the theoretical values of dipole moment, it is 3.95 diopter for nitrobenzene, and it is 6.10 diopter for para-nitroaniline, right? So para-nitroaniline has more dipole moment, so it is more polar. It is more polar. Right? So in the statement 1, it is given para-nitroaniline is more polar than nitrobenzene. So this is true. This statement is true. Then in second statement, it is given nitro group has minus M effect. So this is true. NO2 shows minus M effect. Minus M means minus R effect. Now let us see the resonating structures. Now we have benzene ring, and we have here nitro group, which can be written as NO double bond O, right? This is nitro group. So what happens in case of nitro group? This here we have double bond between nitrogen and oxygen. Now the pi electrons of this double bond is transferred to the oxygen atom, and this pi electrons of the ring are transferred here. So due to that, the resonance takes place, and when these electrons are transferred here, here we get a negative charge with a lone pair, and here we get double bond, and here oxygen with negative charge, right? And these two double bonds as it is. Now what happens in next structure? This pi electrons will transfer here. So in next structure, what we get? We get a double bond here, and here we get a negative charge with lone pair, and this as it is nitrogen, oxygen, O negative. Then this pi electrons will transfer here, and in next structure we get negative charge here and a lone pair, and we get double bond here, and here double bond N, oxygen, O negative. Then what happens in next structure? Now we have here double bond, so the electrons, pi electrons of this double bond comes here, and again we have this negative charge and electron which comes again here, and the next structure will be double bond here, and here we get nitrogen, double bond O, and here oxygen, right? So these are the 5 resonating structure. As you can see, the NO2 group is withdrawing electron from the ring towards itself, right? So it shows minus M effect. So from here we can say that the second statement, it is true. So both these statements are true. So both these statements are true, but second statement is not explaining the first statement, right? So here the correct option will be option B. Statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. So this is the correct option here. Option B is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.